Keep that open. Close that. Close that. We'll do that one. No, 02 dash 01. This is going to be classes. Maybe some inheritance. Good morning, everybody. Happy Monday to you. I think you guys can hear me okay. See me okay. I can see myself here on the stream. No internet problems today. So we could get some live question answering in the chat. Looking forward to that. Let me close this thing here. Okay. All right, we're back. Give everyone a few minutes here. It is 11:30. I do see about 18 people or so. And we're going to take a few minutes anyway to just kind of talk about assignment 1, to talk about a few other things, and then we'll get started today with our example, notes, and things like that. So, first things first, does anyone have any strong opinions on assignment 1? I will say that I received 19 or so submissions. I think there was like 30 people in the class. And so I wonder if assignment 1 has scared away quite a few people. And we will talk a little bit about how it was. Okay, so we have seemed a bit lengthy, and I'll agree with you on that one. Now, we also say we had trouble with the read file and the empty vectors. I did try to cover that as much as I did last week, and I also gave you pretty much code for code all of the read file functions. So if you paid attention to that, you should have been able to at least open that file and focus mostly on the other stuff. Yeah, so the truth is, yeah, it was a big assignment. There's not much that I can really say other than that our future assignments, some of them may be that long, most of them shouldn't. Assignment 2 is actually a redo of assignment 1, except you're using classes. So for assignment 2, as long as you did assignment 1, you shouldn't be spending too much time, or as much time as you did on assignment 1. But the truth is, we really need to kind of catch you guys up with the assignment 135 material. But definitely don't expect future assignments to be that crazy. And plus, I'll always try to add my comments in where I can. Now, there's a few things I want to mention. For one is, I didn't see really anybody asking any questions in the Discord chat. And I got quite a few kind of emails and like private messages. I would just say emails, which were more like asking for extensions and things like that. And I would say the truth about this class is you need to look at the assignments earlier. For example, this wasn't a lengthy assignment, but I think you had a little under 2 weeks to do it, you know? So you got to look at them early. They're not supposed to take 2 weeks' time, but you're definitely not going to be able to cram things in a day always. And you really need to ask me questions. I know that you might be scared to ask me questions because I might think that they're a stupid question. But the truth is, you know, we're all virtual at this time, you know, and I can't judge really anybody for what's going on. So if you have to ask questions, I really encourage it, you know, especially if you're stuck on some errors. Yeah, you guys really, you know, I encourage you to abuse me as a resource. Just send me a message and I'll do my best to answer it. I think one person, I mean, I'm not trying to call anybody out, but there was one person in the chat here I see who was asking me questions, and he can attest that I'll answer them, okay? So please do that, you know, especially if it is a lengthy assignment. I don't want you banging your head against the wall for 4 days. And that's why I'm here. And let's also on the side of that, I'm gonna show you guys two things. There are tutors available to you, so I'll screenshot these. You can also write them down. So if you don't want to talk to me for some reason, though, I really want you guys to talk to me, you know? Because I think it helps both of us. It especially will make grading easier for me. So here's number one. Where's my snipping tool? I don't know if I can zoom in on this. So this is tutor number one. I'm going to save this little image in the web campus. So once again, if you don't want to ask me questions, and let me just say one more thing on that. If you're going to send me an email and not a Discord message, please send me an email at the email listed on the syllabus. Do not message me through web campus because my web campus is tied to my student email. And I won't always see it on time. So if you have to email me, please use the syllabus email. But back to this, you have two tutors available. This guy's name is Jacob Cawley. And he seems to be available on Monday, Wednesday, and Friday for quite a few hours. So it looks like you can just go to this link and schedule a virtual engineering tutoring if you would like. So he can help you guys. And so let me go ahead and save that. Not there. And then there's also another one. So if for some reason you don't like this guy, or, you know, he's got like a bad time for you, then there's even another one. So I'm just going to name this guy Tutor Jacob. And then the next one that we're looking at here is, looks like his name is Jordan Cagle. So let me bring him into this as well. So I'll just display that on the screen for a moment. Looks like he's available on Tuesday, Thursday, and Sunday. So it looks like you guys have plenty of tutoring opportunities. But once again, just send me a message, you know. I'll answer your questions. I promise I won't make you feel stupid. I'm just going to, you know, do my best. And I want you guys to succeed, you know. So there's that. Now, to talk about, who's this? Jordan. Oh, we're not going to talk about assignment 2 today. It is uploaded, okay? It's here, so you can look at it, you know. I wouldn't say you have to yet. On Thursday, I will have my comments ready for, so you can see here that this CPP file says no comments yet. That's because I haven't had a chance. But on Thursday, I will comment these and we'll kind of look through it and talk about what we have to do. Once again, assignment 2 is just like assignment 1, except you're putting all of your code into a class instead. So a lot of your code will probably be copy-paste. So that's kind of cool, I think. There's also, if you look in here, the woman who made this assignment, her name's Dolly Jorgensen. She has a link here on YouTube. But in the link, she doesn't really cover the skeleton code. She just goes through the PDF. So you might as well just wait till Thursday. And currently, the due date for that is set to be next Monday at 11:59 p.m. with the late due date at 12:59 p.m. on Tuesday. So you have about a week. And please at least look at it by Thursday. Or do the best you can and ask me the questions. You know what I mean? So, with that covered, we did the tutors and we just mentioned assignment 2. You guys should have watched the video lecture from last Wednesday, hopefully, if you had the chance. If you didn't, I would not say it's a huge deal. You may have to go back to reference it. But I will be kind of just quickly reviewing some of the stuff that I had talked about in that video today. As we finish up our last example, when we're talking about classes. And I repeat myself a lot. So you may just kind of learn it all today, depending on how intuitive you are. So let's set up a CPP file here. I will be coding it straight from scratch. We'll call this, I don't know, the date. And to be fair, I will mention that this file that I'm about to code is already available to you. If you come to this 27 date before class, we're about to talk about constructor destructors, so you even kind of have this code, even though I will be uploading the code we typed today. And if you weren't paying attention in that lecture video, the notes that we're talking about today are right here as well. So I kind of just read through these. And I'll probably ask you guys a few questions about it today to keep you engaged. We have one question. It says, in the real world, what approach would we use more? The way we did assignment 1 or using classes in assignment 2? In the real world, you would use classes most often. The read file, it's kind of a toss-up, I'd say. I would say yeah, in the real world, you would use a class. I wouldn't say it's exactly the way that we are about to implement in assignment 2, since we're just learning about classes. But there would probably be one class that is for the database. And so that class would contain all of your read file functions and your search functions. And then within that class, there would be another class, which would be the AIS data type for a ship. So you would actually have two classes, one for the whole database and then one just for the data type. And so that's probably the most real world approach that we would use for that. And when I'm doing my comments, I might even make a change to that. Let's see. We'll see about that. I will be working on that as soon as I can. But I do have a lot going on myself. But I'll send a message as soon as I can. Okay, so to talk about classes again, if you recall from the lecture, and we'll just kind of briefly talk about these. That's my cat being ridiculous. She'll get out of here in no time. We did talk about function overloading. Just real quick, that's when we use the same function name, but we use different parameters. So I'll include that in the example, but it's very simple. Notice here we've got these four examples here in which they all have the exact same name except their parameters are different, and they have different bodies. These guys kind of have the same bodies, but that's what function overloading is. And then we introduced object-oriented programming. These are just definitions, so I'm not going to talk about that. Recall that structs and classes are exactly the same. They are exactly the same, except we have these things called access modifiers, in which in the struct, everything is public access by default, and in the class, everything is private access by default. But otherwise, they're exactly the same, so you shouldn't be too scared of classes. And recall that public members are accessible to all things, and private members are only accessible to things within the class. We're not going to talk about protected members yet. A member is just some variable or function that belongs to our object. We can initialize members, so we'll include that in our example today. The rule of thumb to remember for classes and structs, this is something that we might ask on a test. If your object has methods or functions, we should be using classes. But if it's just data, like in assignment 1, where it's just a bunch of variables, then we use the struct. And in general, you'll see that functions are usually the public members, and the private variables, or the variables are always private. And this is a good way. Let's actually just stop talking about the notes and let's do some code. So we're doing the same example that we did, but this time we're adding some more stuff. So we're looking at our class point2d, and we need to add our access modifiers here, in which some of our members will be either public or private. And so, as I said, the rule of thumb in general is that our variables will be private. Now, what is the benefit of this? So in a geometric point in general, we're dealing with an x point and a y point. Now you notice here that I've initialized both of them to 0, and that's totally fine. Now the benefit to having these as private is that somewhere in int main, which we will have for this example today anyway, if these values happen to be public instead, at any point, could I just access them and change them to whatever I want? So let's say we've got p1 as our point, and at some point I could just say p1.x is equal to, negative 2072 or something. Now, what if, is this always a problem? Especially because sometimes we talk about using functions. We're going to kind of skip over this static and const, come back to it. But we talk about this thing here, in which we can use getters and setters, in which we make public member functions that will work with these variables, these private variables, so that we have some way to access them. And so we'll come back to this, but let's go ahead and quickly do our getters and our setters. So since these are private, I can make these functions that are within this class that I can use to get these values. So if we're going to do a getter, we're most likely going to return some variable that's within the private list, right? And so what type are these variables? They happen to be integers. And so a getter will return an integer. So we'll say int. And we've got a question here. So Peter asks, if we had a class where all variables were private, would you still put the access modifiers anyway? Well, that's a good question. if you come look at our notes here, we'll recall that classes have private access by default. So in fact, if we don't have this or this, and then even if we have our int get x here, which we'll use, these would be private by default because there's nothing listed. Does that answer your question? And when we use a struct, and I put int x, I know I'm not doing this syntactically correct, int y, these are public by default unless I say that these are private. So that's really the only difference there. So if you didn't include any access modifiers with your class, everything would be private. But it would be kind of hard to work with an object like that if there's no way that we could access it. So I don't think you'll ever kind of come across that in the real world. Yes, the answer to that question there, Sive says, could you omit the private modifier since it's already in the class? You can. So let's do that just for fun. We'll see that it should compile just fine. Everything up here will be private by default since it's not listed underneath anything. And then as soon as we mention that something's public, it changes. So let's go ahead and just work with it for now. I always like to do this just because it's easy to read. You know, it's kind of like context. If you're reading a book, you know, this just makes everything so obvious for people, even if they don't know about classes and stuff like that. So we're doing our get x. This is a very simple function, right? In which we're just going to return the x value. It's called get x. Let's return the x. Now I'll ask for some class participation here. If you watched the video, do you think that there's anything that we should add to this function? Because notice that this function is not altering object in any way. Notice that it's just returning some value and it's not changing it. Yes, very good. So this should be a constant function. And this const assures that this getter cannot change any of these variables. So very good. I'm happy to see that. So we can just make a get y as well, which will be a constant function because it's not altering our object in any way. It's just returning a value. And now let's do our setters. And we'll finally come back to this example that I was talking about. In this sense, we're just making a function. The setter doesn't have to return anything, right? Because the setter's job is to actually set these equal to some value. So it can be a void type. I'll just call it set points as I did in the previous videos. Int x1, int y1. And in here, we'll just say x is equal to x1 and y is equal to y1. Now, what is the point if we have a function that's like this? And I'll even ask you guys, you know, for some critical thinking here. You don't have to know the answer to this. But just, you know, off the top of your head, do you think that there's any benefit here to using this kind of setter as opposed to just making x and y public? Because the way this is written, this is just the same thing, right? If I were to do p1y equals negative 2072, this is exactly the same thing as doing set points. I gotta turn off my IntelliSense. It's exactly the same thing as doing that. So, I know it might seem kind of weird, but a really good benefit of having a setter is that you can actually kind of do some error checking in here. So what if our point was only in the positive domain and someone tried to call set points with a negative value? Within this setter, I could be like, if x1 is less than 0, you know, see out an error and say like, you know, this is invalid. And so in a way, we're granting like restricted access to these variables, and we're preventing users from setting these to any sort of variable that we don't want. So that's just a little example. And you should recall that. Let me put this in the notes and I'll update that because that's a good thing to mention. It's a good thing to remember. And underneath our setters here, whoops. What's going on here? All right. Underneath our setter here, setters can be used to check for errors, things like that. So it's always good to remember that. Since we're keeping things simple, I'm not going to include this, but we did put it in the notes, right? So you can always include some code in this setter to check your parameters to make sure they're exactly what you want. So we talked about that stuff. We talked about static members. I know I pulled the notes open 10 times, but will anyone tell me what a static thing is? What it means? We're going to have a static int point count, and we're going to have some member functions. There's quite a few. And yeah, and the simplest answer is there can only be one for all instances of the class. That's exactly what it means. And, you know, okay, I'll give it to you guys. There's two different statics, right? I'll give it to you guys. There's two different statics. We have a static variable, and we have something called a static member. And a static member only has to do with classes. So yeah, Aaron got it right. WVN Ton here got it right. So there's two ways, right? A static variable is allocated before the runtime. So this point P1 here is a static variable. You guys have always used static variables. You don't know what a dynamic variable is yet, but I have talked about dynamic things. But that's a static variable. A static member means that there can only be one. Meaning that every point, which will have 2.2Ds, right? We'll have a point, let's do that, point 2D P1 and P2. Each of these have their separate X and Y values. So this one has its own X and this one has its own X. But the moment we put a static int in here, it means that there's only one for all objects. So what this is a static point count, and we use this value to keep track of how many points are in our program. And then we're going to include a static member function that is a getter. Might as well put it underneath the getters. I don't see why not. And its job is to get this point count. So we're going to call this a static int, because that's what it's going to return. And it's just going to call it get point count. Can static member functions be constant? Correct. No, they cannot. Because there's only one. There's only one of these functions for all objects. And so it's not going to be working with any objects anyway, right? That makes sense. This can't be constant because, in a way, it kind of already is. So static member functions can never be constant. So those are our static values. We talked about our consts. We talked about our getters and our setters. I'm very happy Thank you for talking to me in the chat today. I appreciate it. All right, let's talk about our constructors and our destructors. And we're doing good. Before we do that, I'll just include 2 function overloads to remind you guys what those look like. Let's just have a few void print point functions. In this print point function, we'll just do a nice cout. I'm even just going to copy paste it because, you know, unless I didn't do it. Let me just take a look here. This looks good. Okay. So we'll have one print point function. This guy should be constant, right? Because he's not altering the object in any way. And this one, we're going to do an overload, a function overload, which means it has the exact same name, except it has different parameters. So in this one, we'll pass in a character, and we'll have the left character, and we'll have the right character. And so instead, I don't know why I did that. Instead of using this like parentheses here, we're just going to put the L for the left character, like if we want to use a bracket or something. And we're going to put the right character. So we got a little bit of a function overload going on here. And that's all that is. So now let's talk about our constructors. When is a constructor called? I'll ask you that one. And what would the does anyone know how I would do the constructor for this class? Aaron says when a variable is made, that is correct. When the object is created, that is correct. So right down here it says constructor is called here. And we'll even do a little cout here to say there is some code here to remind everybody that there's some code there. It is the name of the class without any data type. That's exactly right. So this constructor of this class is going to be point2d. You just copy it, put it right there. You have to give it some parentheses like it's a function. And then you can give it some body. And so in this body, this is a constructor, right? And this is the default constructor. The reason it's the default is because it has no parameters. And so for fun, things are getting kind of nasty in here, but that's okay. We're just going to cout default constructor so we can pay attention with what's going on in our code. And then we're going to go ahead and increment this point count, right? Because whenever a new point is created, let's keep track of that. Point count plus plus. Now, I didn't initialize this value. This one is kind of hard, and this one will take you a few moments to practice, but we're going to go over this today anyway. How to access things outside of the class. Since there's only one of these, we cannot initialize it within a class, right? Because imagine I tried to initialize this point count in here. I said point count equals 0. The problem with this is that whenever I create a new point, it's going to reset point count to 0. I'll create point 1, point count is now 0. And now I'll create a point 2, point count is now 0. So we can't initialize it within the constructors of objects because there's only one of them. But we can't work with it, right? We just have to remember that it's static. And so if I want to initialize this outside of the class, I just need to kind of copy paste this, and you'll just have to remember this syntax. This syntax is in the notes. I'll just point it out. Here it is. I put it right here. Initializing outside of the class where we have to. So we got to include int Now we got to use this thing called a scope resolution operator, which I mentioned slightly. And we'll be doing a lot of this very shortly. So we'll talk more about what this is. But I need to use this to go into the class to access this value. And I just need to initialize it to be equal to 0. Now it is a private variable, so I know that might be kind of confusing. And we'll see even if the code compiles. It might not. Anyway, so we've initialized that static value, and in our constructors, we'll just increment that point count every time to keep track of how many points we have. Now let's do another constructor, right? Because we can have multiples. Point2d. This one's very easy. We're just going to pass in some parameters, x1 and x2. y1, rather. I wonder if I did that correctly. I did. Now, I'm just going to copy the exact same code here, except this is our parameter constructor. And in this one, I want to initialize x1 to be equal to y1. I would encourage you to do it this way. There's a special way here where you can put a colon after this function prototype here, I guess. So instead of saying something like x1 equals x1 and or y equals y1, instead of doing that, we can just replace this up top here by x1, y, y1. Now there's really no direct benefit yet to doing this, though I'll explain what this does as we talk about inheritance. But in a way, these values get initialized like before the constructor is called. And then if compared to this, if we had it this way, these parameters get initialized after the constructor is called. Because the constructor is called, and then we're within the body. Now we're within the body, and now they're initialized. But in fact, if we do it this way, these values will get initialized like right before the constructor is called. So that's kind of why we do that. And we'll talk about it more later when we talk about inheritance. But these are exactly the same. So just don't get scared or anything. And just to kind of give you an idea of what this looks like, let's pretend like I didn't initialize these values at all. And if I wanted to do the exact same thing on the default constructor, very easily I can do that. But instead of x1, y1, we're just going to put the literal values in there, 0 and 0. Peter asks, are libraries also classes? And I like I love this. You say, I'm wondering because of using the scope resolution operator with std. So yes, in a way, yes. Library itself is not a class, but what the library does is it brings in like a bigger scope. So when you do something like include vector, I guess is a good one. You now have access to all of the scopes within that class. And so I might even be able to come down here and see what I can find by just doing something like cout vector, which would be the namespace. And then in here, there's probably some functions that I can't see yet. In assignment 1, I kind of gave you this hint when in your search vessel by name function, I said that you could just kind of do this quick little if statement that says if whatever your string is dot find whatever the substring is does not equal string and pause. Now I'm not trying to confuse you or anything, I'm just mentioning it. In this function, it'll look for this substring within this string. And if it finds it, it will return the index at which it found it. But if it doesn't find it, it returns this value like -1. And the -1 that it returns is not exactly an integer type. So you might almost just say something like this. That's kind of what this statement is saying. If the index is not -1, then you found it. But since they're not exactly the same type, we use like this endpause thing. And what this is a static, this endpause is a static member variable. It's just like point count. It's a static member of the string class in which we use this string resolution or the scope resolution operator to get into the string class. And then also, if you don't use this std thing, whenever you want to print something, you have to use the scope resolution operator to access whatever cout is. So yeah, you're exactly right, Peter. I'm so glad that you noticed that. And this thing here shouldn't be scary anymore. It just means we're going inside some class. In this class, this is the std class. And we're going to pull something out of there. And this is probably a static member. This is a static iStream. All right. So let's kind of take a step back here. Redo all the things that we undid. And we were talking about constructors, right? So the constructors should be good. Let's just kind of... this should all be review from, you know, the YouTube video. So I don't mean to bore anybody, but I think it's good anyway. And let's go ahead and, like, call this default constructor, right? And let's, or not the default, but the parameter constructor here. We'll pass in some values. And then down here, we'll do a cout. There are... And then we're going to call our get point count, right? So this is a private member, so I can't access it. I can't, like, set it equal to any values from the main. But I do want to read from it. So I do have this static int get point count. So I'm going to call that value by using the scope resolution operator. The scope resolution operator is just these two dots. And then the namespace is this, right? The namespace is this scope here, which is the class point2d. We're going to call get point count. There are this many points. I know we're kind of running off the side here, but we'll say points. Okay. So let's just go compile it, make sure everything's good. Make sure it's all okay. I'm going to connect to Sally here. I don't think I'm still connected. I'll do my 17 zooms. Sally may be experiencing some sassiness, but it appears not. Just was taking a second to remember who I was. Give me special access because I'm an instructor. I'm just kidding. It doesn't do that. Whenever I have problems, you also have problems. Go into our favorite test folder. Delete all of this stuff that I don't like. I'm going to cd to my test folder in the terminal. I'm going to ls to make sure there's nothing in there. I'm going to come to my files. I'm going to grab this C++ file. I'm going to find my last compile statement. I'm going to replace this value. I'm going to type in the name of this file. It's going to compile. And it looks like I have one error, and it's because I'm not returning anything from int main. And I think you guys know this. You don't have to include this. But I'm old school, you know, so I'm just going to stick to my old person ways and leave it there. So everything compiles. So we'll just kind of run through our code real quick, as we always do, to remind you guys what's going on, what we did. Trying to grab this in a way that we can kind of see it. My face won't be in the way. So the very first thing that happens in main is we call a default constructor right. That's because here we declared a point, a static variable, not a static member, a static variable, and there's no parameters with it. So what did it call? It called the constructor that has no parameters. And it said, hey, this is the default constructor. And then the next thing that happened in main was it said, see out, there is some code here, right? So we can see that here on the screen. I might try to pull this over here. We need more space. That was loud. I'm sorry if you heard that. So we see out some code there, and then we called another constructor, but this one's the parameter constructor, right? That one's the default, this one's the parameter. Since we passed some parameters, we got the parameter constructor. And then I called set points. Seems like it worked fine. And then I said, how many points are there? And there's exactly 2 points. Because in each constructor, we incremented this static member once. So everything should have been review up to this point, and we should be good to go. So now we're going to introduce something new. It says, could you use something like using namespace point2d to avoid using the scope resolution operator to access static members in point2d? The short answer to that is yes. We could try it, though I'm not sure how many namespaces that we could use. Let's try it for fun. Why not? I've never really done this before, but the compiler may say too many namespaces being used, or it may just be okay with it. It says point2d is not a namespace name. Well, maybe that's because we haven't declared it yet. So let me bring it down here instead. After we've declared our class to see if that fixes it. That'd be kind of nice, you know, if you could just use that namespace there and then you wouldn't have to even worry about it. But actually, I'll show you something better that you could do. But let's see. G++. It says no, it's not a namespace. So no, I guess not. But I'll have to look more into that because I do think that you should be able to do something like that. But let me show you kind of a backwards way of doing that. Let's do a backwards way. How about instead you make a global function called getPointCount? And what does it return? It returns the namespaced version of getPointCount. How's that? And then this will compile. I'm sure that will compile now. No problems. Though, why did you do that? Any day now, Sally. Thanks. It compiles. Now we run it. And that works just fine. That works, right? Okay. So, that's a backwards way of doing that. Now we're going to kind of come into our notes here, and we're going to talk about our new stuff. Are there any questions about any of this stuff? Yes, it is an amazing strat. 100%. It works. Classes can't have multiple constructors. Constructors have the same name. It does not have a type. And you can have none, right? I mentioned that, I think, up here. Maybe I did, maybe I didn't. You can also have no constructors. Okay, I put that there. So now we're going to talk about a destructor. This is the new stuff. So destructor, what do I say here in the notes? This is like a constructor, but the opposite. So it's only called when an object goes out of scope. So now we're going to have to step outside of our brains here and see if we can understand what's happening. And in general, this is used to deallocate dynamic memory. So in fact, we're going to make a destructor for this point2D class, though it's really not necessary. Well, actually it is, and it's because we're using a static member. But you'll see what I'm talking about. It has the same name as a class, but with a tilde. And you are only allowed to have one destructor for a class. So remember that. There's only one. There's no parameter destructors. There's just one. And you do not have to include it. Just like I have demonstrated by compiling this code that has no destructors. So if we zoom out here, well, I won't do that yet, but we will soon. I'm just going to add in here our destructor values. And before the end of class today, we're going to make this code super pretty. And I know you guys are going to love it because I love it. And then this code will go up on Web Campus. And then you'll have a wonderful example to help you for all your future classes. So a destructor, I said it's the same thing as a constructor, except it has a tilde. So you put that there, and then bam, there's your tilde. So that's our destructor. And what does a destructor do? Well, I'm going to say in this case, you know, it's whatever code you want to put in here. You could put a for loop and see out 17 smiley faces if you wanted. So, you know, you're allowed to put whatever you want within these brackets. But we're going to say destructor called. And let's say whenever a point is demolished, right, it's destroyed. Let's go ahead and subtract the point count because there's no more point, right? We put a little sad face for him because the point's gone. And so now let's just talk about how this goes. So just by looking at main, can you tell me where point P1 and P2 go out of scope? And roughly between which numbers, if that's number 1, this is number 2, this is number 3, this here is number 4, and this here is number 5. I'm going to put number 5. Number 5 and the return statement are kind of the same. Where would we see this print statement? So I'm just going to ask you between which numbers, and it can be after a number if you'd like. So this destructor called statement, looking inside main, between which numbers, or I guess after a number or before a number, would you expect to see it? So we got an answer here. We say greater than 5. And that is correct. Yeah, that is correct. So this is the scope of main. This is the scope of main. And so as soon as this function returns, the points are going to be destroyed. So let's go ahead and compile that. And let me show you that we'll see both destructor calls at the very end of our program. Any day now, Sally. Thanks. So here you go. This is number 1. That's number 2. That's number 3. That's number 4. And then this is kind of number 5 is in between here, right? And then you can see number 5 is kind of like these two destructors being called at the very end. Now, to give you a better example of this, I'm going to delete our numbers. So we'll print out at this point that there are 2 points. And then let's do some fun stuff. Let's do an if statement. Now, this might be a little confusing to you, right? But this if statement is guaranteed to execute. Do you agree? I think you should. So what I do here is I create a new scope. And how do I know I created a new scope? It's because I've got these 2 little brackets here. And so now within this if statement, I'll make another point. Point 2D P3. And then let's do a C out here, right? And let's say, hey, there's this many points. And then at the very end here, let's print out how many points there are again. So in a way, hey, you know, let's fix this, right? We're smarter than this. We're smarter than this. I would much rather prefer to do this. Let's make main look pretty. This is going to be void. We're going to copy this, and we're going to put .2d right in here. All right, so all I did was I made that a void get point count, and now we're just going to call get point count. Doesn't that look so much better? I think so. Thanks for agreeing with me. Okay. And then one more there. Okay. So let's run this code. And what I'm telling you here is that as soon as we open this new scope, we'll see this constructor being called. And then as soon as it goes out of scope, as soon as it passes this bracket here, Destructors called. So let's see that in real time. It's going to take a moment, as always. All right, so that's P1, that's P2. There are 2 points. P3 is right here, right? Default constructor is called right here. And then there are now 3 points, right? Because that constructor, that is not the right code. That constructor incremented the points, right? Ugh, why am I doing that? And then we see that the destructor is called, and then that there are now 2 points. So does that make sense? Please tell me if it doesn't, right? As soon as this point P3 goes out of scope, meaning I can no longer access it out here. As soon as I put P3, the compiler is going to be like, hey, I don't know what this is. So our destructor gets called. And guess what? If we wanted to make this even more fun, watch this. And let's make our code stand out here a little bit. See out some stars. And we're just going to declare a point within this for loop scope. And we're going to print the point count. And then guess what? The destructor will be called. How many times? Looks like 5 times, right? I'm going to show you this. This is how the code works. It's going to be crazy. We're opening your mind to new things. G++. Let's run that code. Here's my pretty stars. And look, default constructor. There are 3 points. Destructor called. Default constructor. 3 points. Destructor called. Right? You see there's iteration 1. There's iteration 2. There's iteration 3. There's iteration 4. And there's iteration 5. So there was 5 destructors called. There was 5 constructors called. But all the while, we managed to keep the points in check. We managed to keep the points in check. Because in that destructor, we are decrementing our points. See, so if we had an object declared in a function, after the function executes and returns to main, the destructor will be called. That is exactly correct. Is that the only way the destructor is called, or is there another way to get rid of allocated memory? Well, I'm just going to I know what you're asking, and I'm just going to throw a few things in here. There is a way for you to deallocate memory yourself. When it comes to, now let's just look in main here. When it comes to just static variables, the compiler will automatically generate the code for you to deallocate that memory. So the memory deallocation doesn't happen until the very, very end of the program. But when it comes to just destructors, that is the only way to destroy objects. That is the only way. So I couldn't come in here and say p3 dot .2d. Now, in fact, this might compile, but it's not. Like, let me just show you this. I think this will work. I can call the destructor, but it's just gonna execute this code. In fact, it might be better if I made the destructor a private member. But I think I can call this destructor, but then I'll be able to access it afterwards because it didn't go out of scope. So the destructor is just kind of like a function. And sure, I guess you can call it whenever you want. You can even call it up here in your member functions. But the only thing to recall is that objects are always destroyed. Ints, strings, characters, point2ds, they're always destroyed as soon as they go out of scope. And so just by default, look, I messed up my code here a little bit. It says now there are 1 points. Even though that's not true, because there's 2 points. It's just a function. And the function is guaranteed to be called. I guess we put that in the notes. Let's see here. So it's not only called, right? We can call it ourselves. But it is always called when an object goes out of scope. So I know I went on a rant there. Let's see what the follow-up question is. Is memory deallocated only when you travel out of scope? Objects are destroyed only when you travel out of scope. I just ask you to be a little careful with the memory. I know I'm being confusing, so I can't blame you. But the statement is objects are only destroyed when they go out of scope. That's the only time objects are destroyed. Now, if we're using dynamic memory, we're going to deallocate that memory within the destructor, but we're going a little bit too far. That's next week when we talk about memory allocation. But as for your understanding, there is only objects. Objects are destroyed when they go out of scope. So we're going to talk about one more thing today. If you have questions, more questions, keep them coming. I know we've kind of covered a lot here, but really we've only talked about constructors, destructors, static members, constant members, getters, setters, public, private. We've talked about a lot of stuff, you know. And this last thing that we're talking about is not that scary at all. In fact, it's going to make our code look really nice, really pretty. So notice here I declared this function called getPointCount. From your CS135 days, you probably recall that you would do a function prototype here. It's called prototype. And a prototype is just the name in the parameter list. And then you would come down below main and you would put it, right? You would put the, I guess, the definition for the prototype. So the prototype is the name, and the definition is the actual code. So you're used to that, right? Function prototypes go above main. Declarations or definitions go below main. So there's a way to do that with classes. And it's the last bit in the notes. And then we're done with this kind of whole thing. Though we're not done with classes. We'll be playing with destructors and constructors all semester long. So you'll never get enough of them. So you're allowed to declare member functions inside the class. Now let's just remind you what happened here. If I zoom out now, finally, like I said, notice that the class starts here and the class ends all the way down here. Let's even put some big lines because I know you can't read it right now. So here's our big class. And then we come all the way down here, and then this is kind of the end of our class. It's kind of hard to digest in a way. It's kind of hard to see what's going on since we got all of these like function definitions in here. So there's a way for us to bring or leave the prototypes within the class and define the functions outside of the class. So I'm just going to convert that for you right now. And it's very simple. So just like here with the void, whenever you do a void or whenever you do a function prototype, you have to include its type. You have to include its name, right? And you have to include its params. And then whenever you do the definition, right, you copy paste this exact same thing down here. And then you just give it a body. So we're going to do that exactly in the class. So let's first talk about the constructor. Well, I don't like the constructor. That's a weird one. Let's just do these getX functions real quick. So this is int getX const. So let's pretend that this is the prototype. You have to include constant in the prototype, okay? So here's the prototype. Now if I want to put the declaration outside of the class, I'm just going to copy paste it, kinda. Except there's one thing I need here, and it's the scope resolution operator. So all I have to put here is point2d getX. And there you have it. Now I'm just going to convert literally all of these functions at the same time so that the prototypes are only in the class and the definitions are outside of the class. The reason we do this is so that this class prototype is going to be easily digestible by our eyes. And by the way, I proved that these would be private. I proved that. So we're just going to put that back in. And we're just going to do this one by one. So I did the getX and the getY. Let's go ahead and do the point count. This one's a little confusing. We don't have to include the static. I think I mentioned that in the notes. Let me just make sure that that's listed there. And if it's not, then we're going to do it outside of class. We'll just do this. Must include const in definition. You do not include static in definition. So this is for const members, and this is for static members. So notice down here, I included constant. If we're going to do a static member, I don't have to include it. So I'm just going to say int point2d, right? I need that scope resolution operator. Get point count. There it is. And there's the definition. Now, I'm not including very many comments here. I would advise against that, right? I might put something here like returns X. But we're just kind of running out of time here, so I just want to make sure that we get it all compiled and working. But I think you guys get the point, right? So we're going to... Look, I'm actually just going to do this. I'm going to copy this whole thing. I'm just going to paste it outside. And what's the one thing I have to do? Step 1, take out any statics. All right, there's no statics there. Step 2, I have to include my point2d at the front of every name. Point2d, point2d. And what do you know? It's been converted. So then in here, I got to get rid of these definitions. Just like that. Things are looking good. Now let's do the constructors and the destructors. And then we'll be done for the day. If you've got any questions about anything we covered today, go ahead and start thinking about those. I gotta first off shift tab this stuff over. I know there's kind of a lot going on here. So these guys don't have any types, right? So if they don't have a type, I don't actually have to include the type. I just have to put the scope resolution operator there. And it works. Same with this one. Same with this one. And that's it. And I'll actually put my end of class kind of further below. And you could put these below main if you wanted to, as long as the definition is somewhere. So now that we've done that, I don't need that. I don't need that. I don't need that. Let's save it. So now let's zoom out and look at our code. And look, I know it's kind of hard to read probably, but where does the class start? Here. Stop that. Starts here, and where does it end? It ends there. That's it. That's our whole class highlighted. How many members does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total members. What are their names? How are they called? I can see it right here. Looks like we've got 3 getters, 1 setter, 2 member functions. We've got our destructor and our constructor. And we've got our private members. And so it's all nice and pretty. And then Aaron asks, you put this in a header file? Yes, we can put this in a header file. And we'll talk about that next week. Sometime. We will talk about it this semester. And you will code assignments where you use header files. And so this is when you literally take this whole thing, cut it, put it in a header file, and then you just come up here and, you know, type include whatever you called it. We'll call it point 2d.h or something. And there you have it. It would be not much neater. Exactly. You see, it's complaining at me right now because it's like, I don't see this file. And that's because we didn't do it yet. But you could give it a shot. So that's it. So let's just compile it to make sure it's all good before I send it off to you guys. And then I'll just do my wrap-up statements. And I know that there might be some people, okay, looks like it compiled, everything works, there's no problems. This code is yours to reference entirely. It's quite disgusting in this part here. But, you know, since you guys like to do... Since you guys are normally used to this kind of thing where it's below main, we'll just put it all down here below main. That's where all the definitions are. Then we've got just our class and our main. That looks good. End of class here. All right. So that's our code. I'm just going to make sure one more time it compiles and that I didn't mess up anything with my fat finger copy paste. All right, everything looks fine, right? Oh, Sally's thinking about this one. Sally's like, I don't know what you did. So let me just begin my wrap-up statements while Sally thinks about the meaning of life here. Yeah, go ahead. All right. Sally thought about it, and everything's fine. So... assignment 1, for those of you who are scared, please don't be scared. I really want you to just ask me questions. You know what I mean? If you don't have Discord, I will literally... I think I was sending someone messages up until 11:30 p.m. the other night, you know? So, just ask those questions, especially if it's a long assignment, you know? Look at them early. Something I like to do is I like to read the assignment. And if I feel a little scared, then I go to bed. And in fact, your brain will think about it overnight, even though you don't control that. And so sometimes I wake up in the morning and I say, okay, I kind of have an idea on how to start that. So I find that helps me a lot, you know. So even if it's just you look at the assignment and think about it a little bit, that'll help you. You got to ask those questions. Check out the tutors if you're scared of me for some reason. Email me if you don't have Discord. Please don't send me Web Campus messages. I mean, I'll still try to respond to those. But you'll have a much better chance of getting to me through the email that's listed on the syllabus. What else? Assignment 2 is listed. Since we're all supposed to do it, if I decide to make any changes on it, don't look at it till Thursday. I'll extend the due date just a little bit. But before Thursday, I will have comments uploaded. And I may change the assignment. If I happen to change the assignment, then for sure don't look at it till Thursday. It will be pretty much the same, except I might make it prettier. You know, I had a question earlier, and he was asking about the real world stuff, and I said, you know, might as well just make it super real world. I don't see why not. So I think that'd be a great idea. So yeah, and then on Thursday we'll begin inheritance, and we'll talk about the assignment. We'll do a little quick assignment run through. So I think today was better than last week. I hope you guys had a good time. It's 12:44 right now, so you're free to go. Office hours are in 15 minutes. You know, I'll be sitting in there. If you don't see me, it's probably because I'm in a private call with somebody. So just send me a message, you know, if you don't see me. And that's all I got for you today. So this recording will be on YouTube. The files will be on Web Campus. And I'll be available for you guys. So thanks for coming. I'll see you guys next time. And I'll just sit here for a few seconds. See if anyone's got any last minute after class questions. But otherwise, you can leave. Thanks, everybody. Thanks for coming to the stream. It's always good to see you guys. Okay, I'll put this on Web Campus. Tutor Jacob, Tutor Jordan. That's our code. Where's my notes? I should probably save any edits that I made. We'll put that there. Okay, should be good. All right, I'm going to cut the stream. Just come to office hours if you need me. I'll catch you next time. Goodbye.